Hi everybody, welcome to another episode of Pen and Paper Programming. We're going to walk through another problem from Elements of Programming Interviews book, problem 4.9. It's basically asking, check if a decimal integer is a palindrome. Palindrome strings is one which reads the same forwards and backwards. Program should return true for 0, 1, 7, 11, 121, 333, because if you read forward or backward, it gives you the same string. Another big number here, 214 744 7412, 214 744 7412. And it should return false for any number that is negative. 1, 2, because it doesn't read the same. 100, as you see, these numbers do not read the same. So, as the book explains, the sort of first solution probably comes to mind is basically take this integer, convert it to a string, and then iterate through from the beginning and the end. Basically, zero index zero, and index length -1, and keep comparing, and then if they're not equal, walk through. Basically, if they're not equal, return false. But that particular solution would use O of n space, which is not something that we want to do. We could do better than O of n space, and the solution the book is actually providing does not require O of n space complexity. It only requires O of 1 space complexity. So that's what we're going to walk through. But before I actually walk this solution together, there are two things that I think is really important to understand, right? So given a number, let's say 1, 2, 4, 5, 6, 12,456, what we want to be able to do is basically, we want to be able to take this number here, which is the least significant digit, and we want to be able to compare it with the most significant digit, 1, right? So our solution that is going to rely on being able to extract this number and that number. In the binary case, we already walked through some questions. That is, we have ways of doing it, but how do we do it in the case of a decimal? So in the case of a decimal, the least significant digit could be extracted by taking this number and taking the modulo of 10, right? If you take the modulo of 10, you're going to get the remainder, which is in this case 6. But how would you do that with the most significant digit? Well, if you have a number that is 12,000, if you are able to come up with, let's say, 10,000, if you're able to take a modulo of this number, you're going to get the remainder of this, right? 2,456. But that's not what we want. We don't want 2,456 at the moment. What we want is this particular significant digit. So in order for us to do that, the solution is going to rely on floor division in Python. Floor division allows you to basically ignore the remainder and take basically the initial number. In this case, if we were to take 12,456 floor division by 10,000, we would get 1 because we wouldn't get the remainder. I hope that makes sense. But in order for us to actually do that, we have to come up with 10,000. How do we come up with 10,000 to take, in this case, for our input x, 12,456, how do we come up with 10,000? In order for us to do that, we need to determine number of digits in our input x. How many, in order for us to put 4 zeros here, we need to determine how many digits are there. And in order for us to do that, as we will walk through the solution, we are relying on logarithmic functions that are provided in Python math package. If you were to take, just logarithmic in this case is that if you want to come up with 10,000 in this case, what we are basically saying is that given a number like 10,000 in the log base 10, what is the power? What is this number to the power that we need to come up with that, right? In this case, that number would be 4. 10 to the 4th would be 10,000. So that's basically, in our case, when we take this number given and we apply math.log10, and that's basically 10,000, we would be getting, in this case, we would be getting 4. That's what we return. So we know that, by having that, we would say 10 to the 4th, 10,000, and we know that if we were to take the floor division, we would actually get 1, right? So we will walk through this solution together, but these are basically some of the important concepts that you should keep in mind as we are walking through the solution. So let me move this real quick, and we can take a look at this definition here. So let's actually start with an example input and walk through that together. I'm going to pick a integer, a value that is actually a palindrome. So let's say that our x is equal to 1, 2, 3, 2, 1, 1, 2, 3, 2, 1, 1, 2, 3, 2, 1. It reads the same as you see. Let's actually track this together. You walk through, running through this function. Okay, so what we're going to be able to track is that we're going to need to track x. What else we need in our function? We need number of digits, and we need most significant digit mask. So this is the mask that we're going to use to extract the most significant digit. Let's start. So we are taking x, which is 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. That's our input. And it says if x is less than or equal to 0, return x equal 0. Basically, if you're getting a negative number, this is going to return false. If you're getting a 0, it's going to return true because 0 is a palindrome, right? But in our case, that's not a number that's less than or equal to 0. So we're going to continue. So important part, number of digits. Let's determine number of digits here. So we are taking math.log log 10 x, which is 1, 2, 3, 2, 1, and this is going to return us basically in our case, right? So number of digits is going to be, this is going to return us 4 point some number. Again, looking back, just what the example that we went through, what we are saying is that what is the power to the 10 to the power number? What is this number that's going to give me 12,321? That is going to be 10 to the 4th is 10,000. That's going to be some 4 point some number, right? But because of the fact that we are taking the math floor, we're going to ignore the any digits after the decimal point. So we're going to get 4 from here, right here. That's going to return 4 plus 1. That's going to be 5. Number of digits in our case is going to be 5. Most significant digit mask is going to be 10 to the number of digits minus 1. That's going to be 10 to the 4th power, which is, we can just write it here, 10,000. So our most significant digit mask is 10,000. So what happens next? So we're going to iterate through 4i in range, number of digits, floor division by 2. Well, what's happening here is that we are dividing number of digits by 2, ignoring the remainders, numbers after the decimal point, because when we are looking at this number, we're going to come look at the least significant digit and the most significant digit, and we're going to move inwards. Therefore, we don't actually have to go to full length. We have to go through only half the length. By the time we get to the half, if the number is always same, we're going to return true. If not, we're going to return false. That's why basically we are only walking through halfway. Okay, so we come to this x. This is a really important part of the solution, where we are taking x and applying a floor division by the mask. In this case, if you can see it, I'm going to move this up a little bit so I have more space to write. But what's happening here is that we are taking 12,321, and then we are doing floor division by 10,000, which is our mask in this case. What's going to happen is that we're going to ignore all this, right? By that, we basically are getting rid of all this, and then we have 1. So this returns 1. Is this equal to, if it's not equal to x modulo of 10, when we take 12,321 modulo of 10, we're going to get 1. So in this case, 1 is equal to 1. Therefore, we're not going to return false. We're going to continue. What happens next is that we are going to take x modulo of ms most significant digit mask. That is, again, I'm going to write here, if you don't mind, 12,321, and we're going to apply I'm sorry, this is just a modulo operation, which is 10,000. 10,000 here. What's going to give us is basically going to get rid of this first one, because this is going to give us the 2321 as a remainder. 2321 is a remainder. So our x just became, we got rid of the first most significant digit, 2321. And what happens next is that we are taking x and floor division. We are applying floor division by 10, which is going to be Yes, the reason we are doing that, I'm sorry, just for a pause, right? What we are doing is basically we got rid of the most significant digit. Now we got to get rid of the least significant digit. In this case, our x is going to become, actually, let me write here, that's going to become 23, 2, right? We got rid of the first one, basically got rid of the most significant digit, and this one is getting rid of the least significant digit, and we have 232. And our mass just became, from 10,000, it's divided by 10,000, our mass just became 10 to the second, right? Basically, we got rid of two zeros and that became 100, right? Okay, so we go back to our loop. Now, x, which is our 232, is 232 MSD mask. MSD mask is 100, right? Do we have some space? Let me just try to get a bit more space here. Okay, so 232 apply when we do floor division MSD, which is 100, it's going to basically give us 2, right? 2, and then in the is this equal to x 232 modulo of 10, which is 2 again. This you know, the modulo of 10 gives us this, and floor division by 100 gives us this. They are equal, so we're not going to return false. What happens next is that we are taking x and applying modulo operation to it, so that's going to give us 32, right? Because it's going to get rid of the number 200 digit, and then we're going to apply floor division by 10, which is going to get rid of this digit 2. Then x is going to become 3, right? And then what happens to our mask is that we are dividing it by 100, we are getting rid of 2, our mask becomes 1. And we come back to our range. In this case, 1, x floor division by 1 is giving us 1, and x modulo of 10 is giving us 1. It's the same number. We're not returning false. And then x, which is 3, taking the modulo of MSD mask, which is going to give us x, and then x floor division by 10 is going to give us in this case going to give us 0, I believe, and then we are running out of the loop. We are done pretty much here, and we come back and we are out of the loop. We haven't returned false, and then we are returning true, and then this basically input was a palindrome. I hope overall this makes sense. Again, the most important aspect of this question is then being able to determine how you're going to extract the least significant digit and the most significant digit, and in that case, being able to do that via determining how many digits the given integer has using Python's math log 10 function is going to give us that number. But once you figure that out, actually it's a pretty straightforward question. I hope this makes sense. If you have any questions, just ask in the comments. If you like it, please hit like button and subscribe to the channel, so that will motivate me to go through more questions. Thanks for watching.